Civil engineering is considered the second oldest engineering discipline, with military engineering considered the oldest. Civil engineering is a professional discipline that deals with the design, construction, and maintenance of the physically and naturally built environment, especially public sector works such as roads, bridges, dams, highways, airports, pipelines, sewage and drainage systems, railways, ports and all the rest. The professional discipline of civil engineering offers many opportunities for specialization. Coastal engineers specialize in building coastal structures, like ports, harbors, levees and storm surge barriers, that protect populated areas from flooding and erosion. Environmental engineers specialize in the design and construction of structures and facilities that treat chemical, biological or thermal wastes. There are even geotechnical engineers that analyze the composition of soil to ensure the safety and reliability of building foundations and retaining walls. In this video, we're focusing in on one particular aspect of civil engineering, structural engineering. Structural engineering deals with the design and structural analysis of buildings, bridges, towers, lighthouses, tunnels, and even offshore structures like oil rigs. Structural engineers may use some creativity to design a structure with visual appeal, but they must also ensure that the structure is safe and stable for its intended use. Keep watching to learn more about structural design in civil engineering. Structural design is a highly specialized area of civil engineering. It can be described as a set of methods or tools that are used to determine safe and economical specifications for a structure, and to ensure that a planned structure will be sufficiently strong to carry its intended load. Structural engineers conduct a structural analysis to determine what internal and external forces could affect the structure, then design a structure with the appropriate materials and reinforcements to satisfy the requirements. There is a strong relationship between the professional disciplines of architecture and structural engineering. While architects are normally tasked with designing the visually appealing features of a project, structural engineers place their focus on strength, durability and safety when designing a building. Structural engineers combine the core principles of structural design with a sound background in physics and materials science to ensure that structures are built to withstand the loads and forces that they will encounter during their usage. Civil engineers that design structure for construction projects must be excellent problem solvers. The decisions that structural engineers make during the structural design phase of the project will affect everything from the project cost and duration to the ultimate safety and viability of the structure. Below, we highlight some of the most important factors that structural engineers must consider when designing a building. Structural engineers are primarily concerned with the safety and stability of structures that they design. Structural analysis is the main tool that structural engineers use to ensure that a structure can withstand the various types of forces that it will encounter during its normal operation. A civil engineering designing a subway platform should ensure that the platform will not collapse under the weight of thousands of passengers. A structural engineer designing a railway system should use materials that will not be damaged when a 50,000 pounds railway car is used on the tracks. A structural designer must ensure that the train station they are building won't collapse when snow collects on its rooftops in the winter. Civil engineers investigate three properties of forces when conducting a structural analysis. Magnitude, the size of the force being applied to the structure. Direction, the direction of the force. A strong wind would be acting against the side of the building, while the weight of a heavy snowfall would act downwards, in the direction of gravity. Different systems of materials and reinforcements are required to counteract different types of forces. Position, the position on which the force acts. Structural engineers must assess the effects of anticipated forces on each area of the building, not just on the building as a whole. If you've ever tried to build a tower out of rocks at the beach, you may have encountered the important structural principle that elements of a structure must remain stationary to ensure their stability. The first step is ensuring through geotechnical engineering that the soil beneath the building provides a solid foundation for construction. A solid foundation helps ensure that the structure itself is immovable, and that it can resist external forces. For a structure to remain stationary, the sum of forces acting on it must always equal zero. However, civil engineers know that external forces will be applied to the structure throughout its operation. These can include live loads, such as building occupants and furniture, or environmental loads like wind, snow and earthquakes. In any case, effective structural design requires civil engineers to ensure that a building can absorb applications of external force, maintaining its own equilibrium. Just like a tree branch that doesn't bend will break in the wind, a structure that can't absorb external forces is vulnerable to damage and instability. The selection of appropriate building materials is one of the key responsibilities of structural design. The ability of a structure to withstand external and internal forces, and maintain its own state of equilibrium and stability depends on the properties of the materials from which it is constructed. Structural engineers choose materials based on a number of measured properties that predict their performance in construction applications. Strength, a measure of how well a material can resist an applied stress or load. The opposite of strong is weak. Toughness, a measure of how much energy will cause a given material to crack. The opposite of tough is brittle. Elasticity is a measure of how much a material can be stretched and still return to its shape. Plasticity measures the capacity of a material for plastic deformation. Plastic deformation occurs when a material is stretched beyond its capacity to return to its normal shape. Metals exhibit plastic deformation as they crack, making them tougher than other materials that shatter, such as glass. Imagine that you're a structural designer creating a design for a skyscraper. How will you decide what building materials to use? Because the building is tall and has a face with a high surface area, you know that single greatest risk to your structure is likely to be high winds. In addition, because the building is quite tall, it could be at risk of falling over in an earthquake. If you had a choice between a concrete construction and a steel construction, you'd want to review the properties of both materials and determine how they would affect the safety of your building. When you look up the specifications for a steel construction, you realize that steel is more ductile, it can be plastic elongated by up to 15% before fracturing, whereas concrete exhibits very little plasticity and fractures immediately. Once its threshold for elastic stretch is exceeded, it is quite brittle. You conclude that a material that won't fracture under stress is a better option, and you correctly choose steel as your construction material. Structural design plays an important role in construction projects. Structural design is conducted by a structural engineer, whose role is to ensure the safety, stability, and performance of the structure. Civil engineers use structural analysis to assess the forces that could act on a structure, and to choose materials and reinforcements that will effectively withstand those forces. Structural engineers design buildings, towers, tunnels, bridges and other types of structures through the knowledge and successful application of physics principles and material science. In this video we tried to discuss about what is structural design in civil engineering in brief. Hope you got the facts, and make sure to comment your ideas below. Give a thumbs up if you liked the video. Don't forget to subscribe and support the channel. Share this among your engineering friends. Thanks for watching.